Okay then, so I want to talk a little bit about Idris because Idris is one of these sophisticated programming languages which can implement category theory. Okay, so I want to talk about Idris because Idris is one of these sophisticated computer programming languages which involves dependent type theory. And so there's various different things that you can do in Idris. The syntax is pretty similar to Haskell, so I'm not going to go through a full tutorial of it, but I just wanted to illustrate how we can show certain things. So, for example, this is an example of a sort of pi type in Idris. So I think here, yes, I have a, this is this one at the bottom here. This is a kind of type where we pick, the way that this works is we, this type to the right here, this pi t arrow t, the idea is that we pick a type little t, and then we have this function from t to t. And so basically when we pick a type t and we pick a sort of endomorphism of t, or whatever you want to call it, that's what this pi type corresponds to. And then we have this specific example where if we pick any type v, then we have the identity arrow for v. And this is what we can call our sort of identity type. So basically we're using pi here to talk about the identity. We're talking about all of the identity kind of functions for all the different types simultaneously, because we're having this sort of construct where we can pick the type. And the other sort of really, well, there's lots of very interesting things that you can do in Idris, but one other really sort of profound thing is that you can implement sigma types. So in particular, we have this type here where we pick a type t, and then a member of this sigma type is going to be a type t together with a binary operation for that type. So this is really giving us what mathematicians might call a magma, basically just a set with a binary operation. And then we have an example of one of those here, which is where we pick the natural numbers, and then we have this addition function. And you can see that using this double star notation, we can implement these sort of sigma types in Idris as well. Now, the main thing I wanted to say was about how we can implement category theory. So I actually wrote a document about this. See if I can find it. Okay, so what I'll do, I'll put a link to this in the description, and I'll just quickly scroll down it so that if you want to read this document, maybe I can make it a bit bigger. If you want to read this document, you can just like pause the screen or whatever. It's an efficient way to transmit information. But I mean, basically what I'm doing here is there's a organization which I'm not working for or anything, but I'm very fond of, called Statebox, and they have this library where they implement category theory using Idris. And so I sort of got their code, and I've basically been playing around with it, and I've figured out how to implement discrete categories in that code. Well, it's nothing very fancy really, I was just copying their code, but I've put some work into sort of translating what they're doing to, so that it's basically in this language, lining up with these kind of videos on the foundations of mathematics. So what I've really got here is a sort of description of how it all works. And so this is the code, and I'll just very quickly run through what it's doing. So the idea, okay, here are some links of where I grabbed this code from, but the idea is that we can form this sort of category, and we're basically saying that to make a category, we specify a kind of type called obj, which we can think of as like a set of objects, and then for any pair of objects we have this set of morphisms, so this is like a hom set, and we also have an identity arrow and a function which gives us composition, and we have proof that the left identity and the right identity work, and proof that associativity works. And then given this stuff, let's say we want to implement this kind of function here, which if we have a type, it gives us a discrete category with the objects as elements of that particular type. So discrete category is just a category with no arrows except identity arrows. And so we can do this by having these, so we pick a type A of our choice, and then we have these other functions which fill out the sort of details. So for example, discrete morphism uses identity types to model the morphisms, because basically the here A is like our type of objects, and the sort of arrow sets from X to Y is either going to be like a singleton set if X equals Y, or it's going to be an empty set if X is not equal to Y. And it turns out that that's exactly the way that this identity type X equals Y behaves in Idris. It's either singleton with a single element REFL, or it's empty. And so we can model the discrete morphisms like that. So that would be how this second kind of input to this category theory record thing works. And so in this code, which I'll link to in the description, it goes through everything, and then it makes this category which has this type of objects as Boolean. So basically it's a discrete category of two objects, and then I have this code here which just talks about an arrow of that category. So basically this code is like a really trivial implementation of, the specification of a category, how to make discrete categories, and a specific example of that.